This is a Diebold AccuVote-TS electronic voting machine of the type used in elections in several U.S. states. We studied this machine in our laboratory at Princeton University to evaluate its security and its suitability for conducting elections. The detailed results of our study, including a full technical paper, are available at itpolicy.princeton.edu/voting. The behavior of voting machines is controlled by computer software. The software that tallies votes on this machine was written by Diebold. Our study shows that a criminal who can inject malicious software into this voting machine can control how the votes are tallied. His malicious software can steal votes, and it can cover its tracks so that the theft cannot be detected. To illustrate this danger, we have created in our laboratory a demonstration software program that steals votes. This video will show our demonstration software in operation. We will also show how a criminal can inject malicious software into a voting machine, and how he can create a computer virus that spreads itself between voting machines, injecting malicious software on every machine it infects. We will now show how to steal votes in a simulated election. On the morning of Election Day, the voting machine awaits instructions. The machine appears to be functioning normally, but unbeknownst to any observer, it contains malicious software that will steal votes. The machine greets the election workers normally. At this point, the election worker can perform so-called logic and accuracy tests that are supposed to determine whether the machine is functioning correctly. Logic and accuracy testing is essentially a pretend election. The worker casts pretend ballots, and then the machine counts the pretend votes. The election worker makes sure that the pretend count is correct. Our vote-stealing software can tell that the worker is doing logic and accuracy testing, so this is not a real election. It allows the pretend votes to be counted correctly, so that the machine passes the test. Everything still looks normal. Now the election worker tells the machine to start the election. The machine prints out a paper tape showing that no votes have been recorded yet. The election has begun. The first voter approaches the machine to cast his vote. The election workers have given him a voter card, which will allow him to cast one vote. He inserts the voter card into the machine, and the machine presents him with a ballot. In this example election, there are two candidates for president, George Washington and Benedict Arnold. The voter chooses George Washington. The machine asks him to confirm his vote, and he does so. The machine ejects the voter card after marking it as used. That's one vote for George Washington. 4 more voters cast their votes. They vote for George Washington, Benedict Arnold, George Washington, and George Washington. The correct result for this election is George Washington 4 votes, Benedict Arnold 1 vote. Election day is now over. An election worker approaches the machine, inserts a supervisor card, and tells the machine to end the election. The machine prints out a paper tape announcing the results. The tape shows that Benedict Arnold won the election, 3 votes to 2. This result is incorrect. Malicious software stole votes from George Washington and gave them to Benedict Arnold. The voting machine recorded the election results on its internal memory and on a removable memory card. A poll worker opens the side of the machine and removes the memory card. The memory card, when examined by technicians, also shows that Benedict Arnold won the election, 3 votes to 2. Every record kept by the voting machine shows the same fraudulent result. Arnold 3, Washington 2. How did this happen? The voting machine was running Diebold's election software, but it was also silently running our demonstration vote-stealing software. And our software was able to steal votes without being detected. When the election ends, the vote-stealing software can delete itself from the voting machine. No evidence remains that the machine was ever hijacked. No evidence remains that any votes were stolen. As far as anyone can tell, the election was conducted fairly. But the result is fraudulent. This vote-stealing attack requires injecting malicious software into the voting machine. Anyone who has access to a voting machine for a few minutes can install malicious code. Here is one way to do so. In advance, we prepare a memory card containing our malicious software. When we get a few minutes alone with the machine, we first open the side door. We can do this with a key. There are thousands of keys in circulation, and any hardware store will copy them. Even without a key, the lock is easily picked. One member of our team can consistently pick the lock in less than 10 seconds. Or we can simply remove a few screws and lift off the machine's cover. Next, we remove any memory card that is already in the machine and insert our prepared memory card. We press the power button to boot the machine. When the machine boots, it will automatically install our malicious software for us. The machine makes a musical noise when it boots, but we can suppress this noise by inserting headphones into the machine. We remove our memory card, replace any card that was there before, and close the door. Our malicious code is now installed on the machine. The total elapsed time is less than 1 minute. Due to design flaws in the Diebold AccuVote-TS voting machine, it is possible to construct a computer virus that infects these machines and spreads automatically from one machine to many others. To illustrate this, we have constructed a demonstration virus in our lab. The machines use removable memory cards to distribute software updates and store the results of elections. The memory cards function similarly to floppy disks or thumb drives on ordinary PCs. Memory cards act as carriers for the virus. When a memory card is inserted into an infected machine, the machine copies the virus onto that memory card. If the memory card is removed and later put into another machine, the virus spreads from the memory card to the new machine. In this way, the virus can spread from one infected machine to an entire population of machines. The virus can carry with it a malicious payload program that is installed on every infected machine. For example, our demonstration virus carries our vote-stealing software, so that every machine that catches the virus will steal votes. A criminal could use this kind of virus to install malicious software on many voting machines, even if he has access to only a few machines, or even only one. By planting a virus far enough in advance, he can ensure that a significant number of machines will steal votes on election day. These problems, taken together, pose a very serious threat to the security of the elections conducted on Diebold AccuVote-TS voting machines. We urge public officials to address these issues promptly. More details, including a full technical paper containing a more complete security analysis and a discussion of mitigation strategies, can be found on our website at itpolicy.princeton.edu/voting.